Hello everybody, I will start today another live coding session. So firstly, I'm so sorry for my bad audio today because I'm traveling and I'm in Thailand and I don't have a good microphone in my house, so I'm using the built-in Mac microphone, which is not so clear I guess. But yeah, that being said, let me get started. So today I will solve this question, maximum subarray. Yep. So in this question, I'm given an integer array nums, and I will find the subarray with the largest sum, and I will return its sum. Okay. So subarray is a contiguous non-empty sequence of elements within an array. Okay. So in this question, the input should be integer array nums, and the output should be the largest sum of any subarray. And one thing I'd like to make sure is that I have to take at least one element when I take subarray in this question. I know this because I've solved this question before and I made a mistake on that. It was a bit ambiguous with this expression, but for example, if this case, I should return -1. So I don't have the, I'm not allowed to take empty subarray and the sum whose sum is 0. It isn't allowed. Yeah. Okay. So that being said, I will think of the solution of this question. So firstly, I will think of this example. So in this case, it's a bit wrong. Let me go with only this. Okay, so for this example, yeah, if I take only this, it should be -2, and if I take this until 4, this should be 2, and if I take from this to this, it should be -1. And if we take all the elements as a subarray, it becomes 3. Yeah. And in that way, I will take a look at each, subarray and calculate the sum of that. Then I will return the largest one. Definitely, that's a brute force approach, and it will take n squared time. Yeah. So, because I will think of the start index and end index combination, 0 n times n minus 1 combination of that. Oh, no, actually it's n squared. Oh, wait, 0 n times, oh sorry, so it should be, firstly, if I take this as start index, there are n options. If I take this as a start index, I have n minus 1 options. So in total, it should be n times n minus 1 plus n minus 2 plus blah, 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 1. So it should be n times n plus 1 divided by 2. So it should be n squared. But also, for each subarray, I have to take care of each element in the subarray, and I traverse and get a sum. It takes O of n, so in total it should be O of n cubed time complexity. Obviously, this can be optimized with, you calculating the suffix sum. With the suffix sum array, the cost to calculate each subarray sum becomes the constant time, so it becomes n squared. Okay, that's the brute force approach. But there is another solution which I can optimize more with dynamic programming. So with dynamic programming, I will think for each element, I will think what's the maximum subarray sum if the last index is this negative 2? In this case, it's only negative 2. So I would say, yeah, and I would think, what if the maximum sum array which ends with this 4? So if I think of that, I have two options. Oh, by the way, I have to first say, I definitely have to use this 4. Yeah, because empty subarray isn't allowed. So the premise is that I use this 4. And I have two options. I will use the maximum subarray which ends with negative 2 and concatenate that maximum subarray with 4. That's the first option. The second option is that I don't use subarray before negative 2. So I mean, only 4 is the subarray. So there are two options, and either of them should be the maximum subarray, which ends with 4. Yeah, and so let me write it down. And in this case, I should throw away dp negative 2 because it's now negative number, negative 2. So in this case, it should be 4. And I will think of this negative 3. In the same way, it's a bit ambiguous. Sorry, it should be index. Okay, I have two choices. And as a premise, I have to choose this negative 3. And being said that negative 3 will be used, I have two choices. I will use the maximum subarray which ends with index 1. Yeah. And concatenate it with negative 3. That's the first option. The second option means I don't use it. So negative 3 only. So again, I will calculate this, and this time the first one should be 4 minus 3 is 1, so it should be 1. Okay, so first n in the end, for index 3, I will think of the maximum subarray which ends with index 3. And for that, I have to use index 3, which is 4, definitely. And I have two choices. I will use the result from the previous one. Or I don't use it. So in this case, because db2 is 1, this should be 1 plus 4 is 5. So 5 is larger. Okay, so this is how I can calculate the maximum subarray sum which ends with each index. So I have to return the maximum of them. Okay, so this is the approach I can take, and with this approach, the time compressive should be O of n, because I do this calculating n steps, and for each is the constant time. Yeah. And for space compressivity, this should be O of 1 constant, because I don't use any extra known constant data structure. Okay. So, and I can say this is the best, reachable time complexity, because at least I have to take a look at each element in the subarray. So, sorry, I have to take a look at each element in the given array. So, O of n is the best complexity, I'm pretty sure. Okay, so I will start my implementation with this. Oh, sorry. And in this way, I don't have to memorize each DP0, DP1, DP2, DP3 result. I just have to keep track of the last result and also maximum sum to be returned. In that way, the space complexity should be over 1. Sorry, I was a bit ambiguous on that. Okay. So I will initiate the global max with the first element. I have to take care. I can't begin with 0 because in that, for example, in this case, the maximum subarray sum to be returned is -2, which is smaller than 0. So I cannot start global max with 0. Okay. And last max, it should be 0. Yeah, because this is theoretically just doing, instead of this, I'm doing something like so if by setting last max is 0, dp0, the first result, becomes always the first number, -2 in this case. Yeah. Okay. Okay, so I finished the implementation. So quickly reviewing this, in line 33 and 34, I initiate the global max sum, which is eventually returned, and last max sum. And in line 37, for each last element, in line 36, I take a look at each num, and current max sum is, as I said, the maximum sum which ends with the current num. Yeah, and I can calculate it in this way. Yeah, as I said. And in line 38, I update the global max sum with current max sum, and in line 39, I make sure that the last max sum is updated with the current max sum, and iteration continues. Then in the end, I return global max sum. Okay, so let me walk through my code with some example. I'd like to use the very simple example. Like this. So this is a case when the whole subarray is the maximum one. Oh, let me go with this. In this case, 2, 5 is the one to be chosen. And the maximum subarray sum is 7. Okay. So in this case, okay. I initiate this with -3 and last max sum is 0. Okay, and in line 41, when num is -3, current max sum is 0 plus 0 minus 3 or minus 3. Yeah, both are the same. It should be negative 3. So in line 43, global max sum is updated with negative 3. It's the same. Okay, and in line 44, last max sum is updated with current max sum, negative 3. And in line 41, num is 2. So here, in line 42, current max sum is updated with maximum of negative 3 plus 2 or 2. So this should be 2. Yeah. So global max sum is updated with 2 and last max sum is updated with 2 again. 2 also. Then in the end, I take a look at num5 in line 41. In 42, current max sum is equal to max of 5. Oh, sorry. So last max sum is now 2, so 2 plus 5 or 5. So it should be 2 plus 5 is 7. So current max sum is now 7. So global max sum is updated with this because this is larger than current number 2. And last max sum is updated with 7. And in line 46, I have written global max sum, which is 7. Okay, so good. This is as expected. Okay, so I've covered all the lines in my code, and so I'm pretty confident in my code. So I submit this. Good. Great, accepted. Okay, so I quickly wrap up my today's session. So in today's session, I solved the question maximum subarray. And in this question, I'm giving an integer array nums and return the maximum sub of any subarray. And one thing I had to take care is that in this question, subarray cannot be an empty array. Okay, that being said, I came up with 3 solutions. Yeah, the first one is brute force approach and cube time complexity. Yeah, so I will think of every possible subarray and I return the maximum sub of them. And it could be optimized with prefix some array pre-calculated, and it becomes n squared time complexity. But I could use dynamic programming, and with that I could solve this question is O of n linear time complexity. The basic idea is that I will think what is the maximum subarray sum which ends with each index. Yeah. So when I think of that, maximum subarray sum, I could use the result from the previous result. Yeah. So that's why I can say I can use the dynamic programming in this question. And with that in my mind, yeah, I could solve the question. And also I had to take care that I have to return the maximum of them because each result just means the maximum subarray sum which ends with that index. And I don't know actually to create the global maximum sum which index should be the end index. So I have to return all of the result. Yeah. Okay, that being said, I finished my today's coding practice. Thank you so much.